So welcome to this edition of Seen and Solved, the podcast where we simplify finishing one episode at a time. I'm your host, Tim Pennington, and today I'm joined by Robin Deal and Jeremy Morgan, and we're going to discuss an intriguing wastewater case study involving an automotive manufacturer that was overspending on ineffective chemistry. And together we're going to discuss the challenges of treating a heavily chelated spent bath, the trade-offs between hauling off wastewater and in-house treatment, and how treatability studies helped find the right coagulant package for this customer.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
Robin, Jeremy, thank you for joining me today. I appreciate it very much.
Thank you for having us, Tim.
Yeah, we're happy to be here, Tim. Thanks so much.
Great. Wastewater, like I said, it affects every finishing operation, whether it's electroplating, anodizing, powder coating. It's a common denominator with all the facilities and the finishing industry. So let's talk about this. Talk about, in this particular customer, the issue of cost to treat. I know that the chemistry that they were using maybe wasn't the right kind, and you all came in. Tell us a bit about that. Give us the backstory on that.
So we were called in to this large automotive manufacturer who had a challenge with a acid pickle that they were using to surface prep their part before they went into their next stage. And the chemistry they were using at the time, it was costing them $30,000 a month to treat this in their wastewater system with their old chemistry.
Right.
And it was taking them 30 days to treat 5,000 gallons of this spent acid.
Wow. Okay.
Yeah. So they did some research and they opted to start doing a haul off of it, just to lighten that load some. So they were able to reduce their cost. But as we all know, as we're moving toward more sustainable and more environmentally friendly options, the directive came down from corporate that they needed to find a way to treat this in-house because they were kicking off a water recycling program. And so they're going to try to reduce as much liquid waste going out the door, either by haul off or through discharge after treatment, by implementing a water recycling system. So that we were approached with a challenge of, could we treat this spent acid pickle in under 7 days and for less than $10,000 a month?
Wow. Okay. Did you think you could do it? That's pretty, those are steep numbers. 1/3 on the time and I guess, 1/3 on the cost too, right?
Yeah, it was very challenging. And that's where we brought Jeremy Morgan on board to kind of spearhead this, to use some of his chemical background knowledge. And really, he took the lead on doing the lab studies and implementing everything. So he can speak more about that.
Yeah, I was going to say, I mean, was there anything right off the bat you saw, Jeremy, or was this sort of you had to dig to see what you were going to do? Or so I guess sometimes these things are obvious, but maybe sometimes they're not. So
no, this one was definitely an iterative process. So we knew the current chemistry that they were using, so obviously we didn't want to go down that path. So after many hours in the lab and many gallons of sample from their line, we actually found a coagulant package that worked well. Previously, they were using a single coagulant and a flocculant. But again, after numerous iterations, we found that a two coagulant package worked much better. A lot of times with processes like these that are heavily chelated, we basically have to balance the charge in order to form flock. And sometimes that can be quite difficult and take a lot of chemistry. So basically by using that dual coagulant package, we were able to reduce the overall amount of chemistry that was needed. And honestly, we produced a much better looking plant effluent and better flock with the package that we found.
Right. But when you say treatability studies, tell me a little bit about that. What does that entail, all encompassing?
So basically, with a treatability study, we have a customer or a prospective customer send us several gallons of sample from their line. Generally, about 4 to 5 gallons or so is what we request, just because that's easy to ship or transport in a 5-gallon pail. Mm-hmm. And then we start with small lab samples, so samples of say 500 mils per sample, and we go through this iterative process of trying different coagulant combinations and amounts until we find something that looks good and performs well and reduces the metal content that we're looking for. Once we find a couple of packages that look good, then we'll scale that up to a larger quantity to make sure that it is scalable and that it will work on larger volumes. From there, we generally present those findings to our customer and go to trial from there and do a full-scale trial.
I was going to say, Robin, you said they at one point decided to haul this off instead of trying to, I guess, fix the problem, right? They were going to, is that what they were going to do with that? Make that decision to pay extra money to haul it off?
They were paying a little over $10,000 a month for haul off, which is why they gave us that cap. If we could do it for under $10,000 a month, then they would consider running it to trial. So some of the other things that we had to take into consideration was their normal waste stream was super easy to treat. Mm-hmm. Produced a little bit of sludge, no problem to treat. But when we started introducing this heavily chelated acid pickle that was full of phosphorus and EDTA and iron and nickel and zinc, the sludge went up, right? So we had to find a balance of how much could we treat without overwhelming their system and still meet their needs for phosphorus, nickel, zinc removal. Right. And so that was another portion of the treatability study that we had to consider, was the sludge generation portion.
Yeah, the sludge generation was definitely the limiting factor. So when we look at these type of applications, we refer to it as the bleed rate. So basically, what percentage of their normal flow can we introduce the tough to treat material at? So with this particular case, we found that the limit on what their equipment can handle solids generation wise was about 2 to 2.5%.
Well, let me ask you this question, Robin, because I wanted to. You said they were taking 30 days to treat this.
Yes.
So are they not treating it every day, or what is it that?
With the chemistry that they were using, they had to bleed in at less than 0.5%, and they would have to routinely stop the bleed in so that they could catch up with the solids removal. So it was just consistently taking them. And what they were finding was, because when they dumped the 5,000-gallon bath from the manufacturing process to their tank, and what they could bleed in from that tank, they had other baths that had to be dumped as well. So that's what they had to have, that tank at least empty enough to handle the next dump, which would happen 7 days later.
I'm assuming this is something you'll typically see when people are giving you these parameters, right? Of, it's probably the worst case situation that they've got going on, but yet they're giving you these parameters. We'll do this if you can reduce costs, reduce time, and also, time is money as well. So, that's, you're saving even more than just, out of pocket costs with that. But yeah, like I said, I think that, is that something out of the ordinary for people to ask you all to do it that way, or?
No, it's not. And it's not unexpected. Our Hubbard-Hall's philosophy is to do more with less. So less chemistry, less sludge production, less manual labor, less time to treat. We 100% captured Hubbard-Hall's mission of doing more with less. And part of that, also part of the cost to treat that we didn't mention earlier, was with sludge production. With their old chemistry, the solids form, the flock formation, was very loose and slimy, and it didn't form solid cake in the filter press. So these guys, the operators, were fighting and struggling with their filter press to open it and clean it and close it and move on to the next cycle. They were running their filter press every 2 to 3 hours, and when it would say it was full, it wouldn't really be full, it'd be blinded. So when we implemented our coagulant package, they could not believe. We also trained them on how to acid wash their system properly. So the filter press to acid wash it. And the first time we ran our solids through it, we got a solid pack, and it took almost 8 hours. The next time it took a solid pack, but it took 6 hours. And so they're keeping their sludge down, so they're not having to shut the system off to keep up with sludge generation.
I see we got Jeremy back, and I had a big question for you, Jeremy. So that you said you kind of mixed several different coagulants, right? Several different of your Hubbard-Hall products, right?
Mm-hmm.
Kind of tested them out. Tell me about that. I mean, what were you using? And how did you just kind of, like I said, do trial and error when you're putting it all together?
A lot of times it is trial and error, but there is a little bit of a method to the madness. So we knew we had a cost cap on this one. So that being said, we wanted to make sure that the selected coagulant was going to fit within those constraints. So normally we don't particularly like to take that route, but we always want to pick the best possible chemistry, not necessarily the cheapest chemistry. But knowing under these circumstances that we had a cost cap, we wanted to make sure that the primary coagulant that was doing the majority of the heavy lifting was going to be a more economical choice. So that was a little bit of the driver for it, but that also led us to the dual coagulant package, where we found that it was great to use the more economical coagulant, but we needed a little nicer, a little more expensive product to go along with it to get the job done. So, we obviously want to do the best that we can for our customers. And sometimes that does involve that cost cap, but at the end of the day, we were able to successfully get to a point where we had great treatability, but still fit within those cost constraints.
Gotcha. I guess the other part is really important is, like it says, really working with, once you've got the solution for them, right? You can't be there every day, so you have to educate them on how to, adjust the coagulants, to meet the requirements, right? How to dial things back. Talk us about that. How do you go through that? And, what sort of process do you go to educate them on this?
Well, basically, we start with our treatability study with the small sample amounts, and we scale it up from there to kind of get ourselves in the ballpark for the demand of how much chemistry to use. So that's generally our starting point, is to start with what the jars told us, what the treatability study told us, and then kind of optimize from there. Generally, we'll want to overshoot just a touch on the chemical usage to start with, and then dial that back to the point that we get to a minimum where the treatability is still good, but at a minimal chemical usage. So sometimes that may take, not necessarily a few hours during the trial phase, but a lot of times it takes several days. So generally for trials, we like to run them for at least a week. This particular case, because it was more complex, we were there on site for a full 2 weeks to make sure that everything was dialed in and running the way it needed to be.
Gotcha. Let's wrap up here real quick. I want to ask each of you to kind of give me one or two takeaways. We'll start with you, Robin. I mean, what are one or two takeaways that you'd want other facilities to know about their system based off of what you all had to do here with us?
Don't overlook sludge production. It can overwhelm your clarifier and get you in trouble very quickly. So when you are bleeding in spent chemistries, keep an eye on how much sludge you're producing and take that into consideration. And two, don't be afraid to ask for that up front, that almost impossible. Treat 5,000 gallons in under 7 days, under $10,000, because in the past, we couldn't do it in 30 days for $30,000. Don't be afraid to ask. We'll be honest with you. We may come back and say, that is not possible. You need to consider these other options. But who knows? We might find a key for you and help you meet your goals.
Right. Yeah. Jeremy, what would your takeaways be from this project?
Well, this particular project, it always helps us out when we have really good, experienced operators to work with. And in this particular case, we had some great people to work with. They were very, very knowledgeable. They knew their system very, very well. So that made the whole optimization process that much easier. So with any kind of trial or with any kind of new startup, when you have experienced people to work with, life is just so much easier. And that was definitely the case here.
Great. Well, this is very, very informative. Like I said, I'm sure there's other shops out there, facilities, maybe having the same problem. I advise them to give you all a call because you could probably solve it, again, in the time frame and the cost that they put out there for you. So thanks, Robin. Thanks, Jeremy. I appreciate you joining us.
Thank you, Tim.
Thanks, Tim.
Thanks for listening to Seen and Solved by Hubbard-Hall. For more episodes, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.